All right, good morning. All right, let's now see what we should be reminded for the coming days. Your lab number 1 will be due today, 2 p.m., right, as we mentioned. So please make sure you submit your best effort and to get your credits. And I'm going to release a solution video shortly after that. So for those of you who might be interested in either you want to do things from scratch together with me, you can do that. But if you only want to look at a particular part of the lab, you want to see how I solve it, you can also click on the timestamp under the YouTube video. You can do either way, all right? And I don't think it's a good idea for your learning if I just release the source code, because there's no point, right? I think maybe the video will be better. But of course, if you really want to see some source code, you can visit my office hour. We can discuss. That's fine too. For your written test number 1, which you took yesterday, I'm going to release your marks either late tomorrow, Thursday, or early Friday. Usually I like to maybe just look over just to see if there's anything I should pay attention to. Okay, so I'm going to release that either tomorrow or Friday. So you can definitely expect to see that. And once you receive the marks, if you got any concern, what I usually do is I don't really deal with any concern over emails about the test. But you're more than welcome to drop by my Zoom office hour, in-person office hour, or just we can make an appointment. We'll talk about it. Okay. But I'll remind you about the policy later. And for your programming test 1, definitely you want to worry about it. I'm going to give you the guide and practice test for sure, either by the end of today or maybe tomorrow, either way. So you definitely got time to actually try and then get a feel by the end of Thursday, hopefully. And then for the mock-up test, let me make it as tentative right now. I'll try to see if I can block some time in Williams Small Center. So you can go there. It's not going to be supervised. You just go there and then log into the computer and get a feel about what a lab test mode is like. There should be no surprise, so this part will be optional. All right, I'll keep you posted. Do you guys have any questions regarding administrative issues about the course? All right, let's now get back to our business for exceptions. Okay. So this is where we were up to, slide number 9. So we should start with slide number 10. Let me do a very quick recap about where we were. Basically, last time we talked about the idea about caller, callee, and also call stack. So these are the 2 very fundamental concepts for you to really grasp the idea about exception, which we'll talk about a lot today, especially in the coding part. And we talked about 2 examples last time. One is about circles, the other one is about bank application. I would say the main point there is to say if you want to handle errors, just doing system.out.print line or even do system.error.print line is not the ultimate way to go. The main reason goes as follows. Let me just review that point very quickly. It's so important to see. If you, for example, go over the circle class again, right? Remember, we got a circle class, we got circle calculator. In this case, the call chain is very easy. We just got a caller here, we got a callee over here. And then when you try to call this particular line, if something goes wrong, meaning that we give a negative radius, what's really not good about this console message mechanism is after the error actually occurred, you are still able to proceed as the normal flow of execution of your program. That's the problem, all right? And when we get to exception today, you will see that you have to distinguish between 2 kinds of flow for your program, normal versus abnormal. Right? That's something you want to keep in mind. And similarly, in the case of the bank application example, let's say we try to do withdrawal over here. If the amount passed by the user happened to be negative, for example, you want to deposit minus $23. In that case, you might just run into error. But you want to make sure the error will not allow you to actually go ahead and execute the line after. It should be disrupted. That would be the ideal solution. Right, that's a very quick recap from last time. And today we're going to see how we can do the error handling properly by exception. My main goal is to really walk you through the fundamental idea about exception, which could be a little bit tricky, right? And then if I cannot finish everything today, I will definitely leave some part for Monday. But we'll see. I want to go very carefully about introducing you the ideas. Okay? The next few minutes will be a little bit dry. Just bear with me. I think it might be nice to just get an idea abstractly what exception is about. I'll go as quickly as possible, but hopefully not to rush. Okay? And then we'll go into very concrete programs. What is an exception? Think about exception, just literal meaning. Something goes wrong. So you want to let your caller know. Let's say I'm the method being called by somebody else. I want to let that somebody know there's something wrong from my side. It's going to be an event whenever an exception happened in which it will occur during the execution of a program. Basically, we talk about executing your program from the top to the bottom, right? Sequential execution. That one's not surprising. And the second point is so important. When I say it will disrupt the normal flow of the program's instruction, I'm going to make it more concrete today when I go over the program. But just remember, whenever exception occur, your program is not going to be executed in the normal flow from top to bottom. It will somehow be interrupted. Just remember that. But we'll see exactly how it looks like. And when an error actually occurs, let's say I'm the method being called, and there's something wrong inside my lines of code. What's going to happen? And like we said, we throw an exception. It's not really a proper English term when you say throw an exception. Don't write this in your English essay, right? It's a very special term in CS, right? So we say we throw an exception. To be more precise, we throw an exception objects. Exceptions themselves are just like objects. Everything is like an object in Java. And so in order to throw an exception, of course, you're going to create it. We're going to show you how you can create it, just like creating a normal object. And also, you're going to hand it over to the runtime system. Here it's a little bit vague. What do you really mean by handing that into the runtime system? That's something we'll explain a little bit further. But you can think about we're going to hand it over to the call stack. So you got to go from the call stack from top to bottom to see where that exception can be properly handled. All right, let's now. And what would the exception object contain? Normally, you wouldn't have to worry so much about the exception object itself. It contains many details, which we don't really have to concern. The only one you will have to know more is about the type of the exception. We'll see a little bit more later. All right, for example. And by the way, pretty much like you can either create your own class or you can use the classes from the library. Similar. For exception classes, either you can create your own exception, which we'll see today, or there are certain exceptions that come from Java library. For example, index out of bound exception, null pointer exception, right? So these are predefined. You can, well, I wouldn't say you use them. You will see them whenever such errors occur. All right, and one more slide, and then we should do some concrete things. Just bear with me, okay? And what's going to happen when an exception actually occurs? What's going to happen? Basically, you just want to remember, when an exception happens, you want to see where that particular method is in the call stack. From there, you're going to do some search, okay? You want to find some block of code to handle the exception. And here, there is a keyword here called exception handler. I want to take some notes for you. Just remember, by the beyond this lecture, whenever we talk about, sorry, over here. Whenever we talk about, I'll make some notes for you. Whenever we talk about exception handler, you have some very specific syntax in Java. You may have seen that before. If not, now is the time to see. It's called a try and catch block. Try some block of code over here. Some part of it might actually got an error, in which case the flow is going to be interrupted. Rather than continue, it's actually going to go over to the so-called catch block. All right? I'm going to make it more concrete for you, but for now, just conceptual. And then we also got a catch block. And the catch block over here is going to specify what kind of error are you expecting. Because sometimes in a single block, there might be multiple sources of error that might occur. For example, in a single block, there might be 3 possible exceptions that might occur. In which case, you want to make sure you can catch either one, each one of them one by one. All right. Well, I'll definitely make more example about this. For now, I just want to sketch what you should know syntactically. All right. This will be something you might need for lab number 2, which will be released on Friday. So you guys definitely have time to think about it. All right. So the point is, whenever you see exception handler, I really meant like a try and catch block. All right. Just remember that. Let's go back. All right, so whenever there's some exception that's being thrown in the call stack, the runtime system, not you, the runtime system is going to look through the first method that actually has this exception handler. I'll make it more concrete, but for now, that's the definition. All right, and you guys can go through this a little bit more, maybe after you have seen the concrete example today. For now, it wouldn't make so much sense to read it over. But I want to show you one diagram over here to make it more visual. Take a look at this thing over here. Of course, I didn't really draw it completely. You can think about this is like a call stack, right? The stack I drew before. This will be the top, and then this will be the bottom. Right? That's a call stack. Take a look at that. Just stare at that with that, and that for just 30 seconds. This is simply one example of how the exception may be handled. And then we'll see different versions just to strengthen your understanding. Just stare at that. Don't worry. If you don't really get it, at least see what's really there. Okay. First of all, this particular call stack represents some call chain. We start with the main method, right? We want to execute it. That's why it will be put on the bottom of the stack. And the main method itself calls another method over here. For now, we just don't need to specify its name, just in general. And this method here itself calls another method. And this method here calls just another method, right? So you can see this part here, it's just about the method call relationship. You can think about this will be the caller, this will be the callee, right? Just give you one example. Think about if you think about this is the caller, and this will be the callee. At the same time, if you consider this one to be the caller, and this will be the callee. And similarly, if you consider this to be the caller, this will be the callee. Right? We said it before. All right, so that's about the method call. Let's now say something goes wrong in this method here, right? If something that goes wrong over here, we are looking for exception handler. Because if something goes wrong, we presume the method is going to throw some exception. And typically, the exception, like a try-catch block, will not be specified in the method itself that caused the error. No, normally we wouldn't. We'll see that later. Sorry. And then from here, the runtime system is going to say, okay, this is the method that goes wrong and throws the exception. Let's try to find out, does its caller have an exception handler? Does it have a try and catch block? If it does, we handle the exception right here, and we are done. No more searching is needed. That's scenario number one. Let me repeat once more. Okay? Something goes wrong here. So an exception is thrown. The runtime system is going to say, let me go to your caller over here. Does it have an exception handler? Meaning, does it have a try and catch block? If it does, we are done. No more searching. Scenario number one. Scenario number two. An error happened, go to its caller, but the caller itself does not have any handler. You have some special syntax for that, which I was talking about. If that caller does not handle the exception, that means we're going to propagate that error to its caller. The original method, its caller, and its caller, like a grand caller, if that makes sense. So we go to this caller over here. Does it contain an exception handler? If it does, we're done. No need to search further, and so on. So what would be the worst scenario? An error happened here. Go to its caller. The caller does not have the try and catch block. Go to its caller. It does not have any exception handler. Go to its caller. It does not have it. And the exception is going to be thrown to the console, which you sometimes see like an exception on the console, like a console message, right? So this visual here pretty much summarizes the kind of mental model you want to have whenever you want to deal with exception. Usually why people find this confusing is there are so many possibilities how the exception is going to end up being handled, right? I just explained that. Any questions so far, conceptually? We're going to see a concrete example for sure. Anyone? All right. If you just got about 50%, I would say it's not too bad, but we're going to see some concrete one. Okay. All right, so that's about it, this diagram here. And let me just go over one more thing, and then we'll do the concrete example. there is the so-called catch or specify requirements. This is to say, as soon as you introduce exception idea into your code, you have to make sure you always satisfy the catch or specify requirements. Otherwise, you're going to have errors in your code, meaning that you're going to have some red underline somewhere, and your program will fail to compile. Let me talk about this requirement right away. The requirement itself is not too difficult. You just got to remember that, and we're going to use this requirement to do some example. Okay? Let me just go to that right away. The next two slides will talk about requirement. I combined it into a single page. It's called the catch or specify. Basically, anytime if your block of code has the potential to have some exception, you have to either catch that exception or you want to specify the exception. Either way, not both, and also not none. If you didn't have any catch or you didn't have any specify, it's going to be an error. If you have both catch and specify, it's redundant, unnecessary. So you should really go for either catch or specify. Either, not both, not none. All right? What does it really mean to catch? To catch here really means to handle. That means you want to do something about it. Okay, let's see some example right away. Let's say I have my circle objects over here, okay, the C. And also, I'm trying to say C dot set radius over here, I'm supposed to pass some value over here. Here, I'm giving you the negative value, but it could be positive, it could be 0, it could be anything. So there is a potential that this line over here has the potential of throwing an exception. We haven't seen how exactly you can throw an exception from the method. That's something we'll see later, not now, okay? If an exception somehow is thrown from here, that way we should really handle that. So that's what the catch solution will do. In that case, we simply wrap around the line that might throw an exception inside the try and catch block. So that's the first solution. All right, just wrap the line that might throw an exception into the try and catch block. And here you can see the catch block over here. We say that this line here might throw this particular exception. Catch that and do something to handle that. This part over here is to say how to handle that exception. All right, that's the first possible solution, which is called the catch solution, which requires some work for that method. The specified solution might connect a little bit more to your real-life experience. For example, if you raise some concern to your academic advisor, they said, oh, why don't you ask somebody from Lausanne? And somebody from Lausanne say, maybe I cannot really solve that. Maybe you can ask somebody in EECS. And then, keep passing you to other people, right? So hopefully, ultimately, you can have somebody who can help you. That's really like a specify, meaning that I don't want to handle the error, not for me. Give to my caller. Ultimately, if nobody is willing to handle the error, you're going to throw that exception to the console, to the user, which is very bad because a student should be really looked after, right, with the ultimate solution. Let's take a look at specify a little bit more closely. Let's say this. We have a bank over here. We have the accounts, all right, pretty much like what we saw before. Now you can see we have don't worry about public again. It's not relevant here. We have a mutator here, withdraw, right? That's what you typically will write. Void, withdraw, and parameter, right? And this is the new bit. You can see after the orange highlight, we have the normal start and end of the method, right? Notice that this new bit has to be inserted between the header of the method. Well, it's part of the header. It should be inserted between the parameter list and also the start of the method, right? This is to say, this method here contains a line inside its body of implementation. And that line potentially may throw this particular exception. And I'm not going to handle that. All right, I'm going to write it down. So this line over here says the following. Number one, some line in the body of implementation may throw, may or may not, may throw an exception. Right? In this case, this one. And by the way, after the throws, you can specify as many exceptions as you want. As I said before, a single block of code may have multiple exceptions. So if you want to specify multiple, which you might do sometimes, in which case you will say comma, another exception, comma, another exception. Okay? You will see that when you do lab 2. Okay? That'll be point number 1. Point number 2 is very important. That exception thrown will not be handled in the current method. In the current method. Right? Very quick recap, and I'll take if you got any question. Whenever there's an exception in your code, somehow it's being introduced, you have to be subject to catch or specify requirements, either to catch or specify one of them. All right? Catch solution simply means in my method here, I'm calling some line which might have the potential of throwing that exception. I'm handling that over here. Wrap it around the try and catch block. That's catch solution. For the specify solution, that means I do have a line of code that might throw the exception, but I choose not to handle it. I just specify it might happen. In which case, you will put it as part of the header of the method. And of course, you can also review these 2 points I just stated. All right, just keep that catch or specify requirements in mind. Basically, to understand exceptions completely, number 1, you need to understand call stack. Number 2, the catch or specify requirements, which we'll keep emphasizing when we do that code example. Okay, guys, any questions so far? Anyone? Before I dive into Eclipse. All right, good. All right. Let's do a little bit of context setup over here. So what I would do is, so this part here, you're already good. That's ready to talk about. All right. It's really about, well, this is a simple example, a little bit contrived, not exactly interesting, but I think that's the simplest one to show to you the different scenarios. Whether you should really handle or not to handle an exception that might occur. Let's take a look. Okay. So what I would suggest is we're going to use the Eclipse over here. And I'll make the source code available to you, so don't worry. Okay, just try to focus on what I'm trying to say here and just ask questions. Okay. I have a new project here, and I'm going to have different versions of the code to show you different scenarios for the exception. For version number 0, I want to set out the context and have some placeholder. Okay, we'll see what it really means. Okay, first of all, I need a new class. And the class I want to call will be just class A. Okay? And then, meanwhile, I'm going to talk about it once I finish the code for version 0. Think to yourself, what's really the caller and callee? Just keep that in mind. All right? Class A, let's try. So what I will have, I don't have any attributes. I just want to have a method. And the method here, let's say a mutator. And then I'll call it MA, method A. And then I'm going to have an integer I. It's going to take some input. Okay, so far it compiles. And then I'm going to have some very simple structure. I would say if the input I is negative, that would mean some error should really occur. But for now, I'm just going to put a placeholder. Okay, error. Maybe I should throw in an exception. Maybe I shouldn't. Okay, I'll just put a placeholder here. All the versions which I'm going to talk about will share the same structure, but the placeholder part is going to be changed a bit. Otherwise, if the error does not occur, I do something else. Do something when there's no error. All right, very simple class A. Are we okay? You can think about class A provides a service by MA method. All right? Let's look at the second class. And you can definitely think about caller-callee relationship. Let's have a second class over here called B. And then for B, I'm going to say similar. Let me say void MB, method B. Also, that one there will also take another integer. Okay, similar. Here, I'm trying to use the service provided by MA. So I should definitely create some context object. I'll say AOA, object A will be new A. Of course, I'm referring to the A here, right? And then I'm going to say OA.MA. And then I'm going to give some value over here. You can see the I here is really referring to the I over here, right? Just to note. And we know pretty well, when we call this line OA.MA, if you go back to MA definition here, potentially it is possible an error might occur. So let's make a note of that. Not necessarily always there will be an error, but it could be. All right. Let's just go back to B, and let's put a note. And error might occur if the I here is less than 0. All right. Are we okay so far? Just two classes, two methods. You definitely should know which one's a caller, which one's a callee, right? Final class. Actually, I got, yes, final class. I want to have another class called tester. All right, that tester there, actually, I really meant to have the main method. Let me see. Good. By the way, in Eclipse, if you want to generate a main method, if you want, you can simply say main and then control space. It will allow you to generate it in case you want to try. Otherwise, you can type it out by yourself too. All right, for this one here, I basically want to read some input from the user so I can use the scanner, right? That's something I briefly mentioned about, maybe in the lab. Okay, scanner and input will be new. Scanner system.in, and make sure you always close it. In between, I would say here, integer. You know what? Let me just do sys out, enter an integer value, just to be more user-friendly. And then, okay, how do we use it? So let's say integer I will be input next int. Like that. Sorry, typo. All right, read it, and let's now try to use the service from class B. So I'm going to say B, OB, new B. And I can say OB.MB. Whatever I read from the user, over here I'm going to pass it as argument into callee MB. Right? And we know pretty well, if you go back to B, B itself may actually have an error when it calls MA. So we are really talking about a call chain of 3 methods involved, which I will try to visualize, but you should really get familiar with such structure. Okay, over here I would say an error might occur from B.MB. All right. Okay, we got 3 classes over here. Do you guys have any questions so far? Right? I kind of developed from scratch, so it will be fresh in your memory. Just remember the relationship between these 3 classes. Okay. I just want to summarize something very quickly, and then we'll be ready to go for exception. All right. All right, so these are the 3 classes, and then let's take a look very quickly. If we start from over here, if you look at these 2 lines, these 2, so that means we'll start from the context of tester, right? And the caller will just be basically the main method, right? The main method, and the callee will be B.MB. And then if we try to go to class B over here, we're inside the context of MB, we're trying to call A.MA, right? So now in the context of B.MB, we're basically calling, oh, actually I can do a little bit better. So context here, it's just a context class. So b.mb, over here we're calling a.ma. Okay, and of course, this one here should be capitalized for class name. If you haven't been familiar with how to identify the context, now would be the time. All right, finally, if we go back to the context of this, and we're calling a.ma, right? So a and then ma. Do we have any method call over here? We don't. So that's kind of the terminating case. We don't need to go further. So I'll just say not applicable. And that's one way to identify all the contexts, and you can also visualize using a call stack. So starting from tester.main, which calls the b.mb, which in turn call a.ma. Right, quick summary. Are we okay so far? We're still reviewing kind of what we learned from Monday, all right? And let me give you some look ahead about how we're going to proceed with the example. Hopefully it wouldn't be so confusing. It's very logical. Given 3 classes over here in the caller, callee, or in the call stack, we're going to see if something goes wrong from a.ma. If something goes wrong over here, exception. Where can that exception be handled? Typically, we don't handle the exception in the same class that creates the exception. We don't do that normally. Okay, let's not worry about why, but for now, let's take it for granted. Okay, so that means we got different possibility. Possibility number 1, an error occur over here, or more precisely, an error occur over here, which would be propagated to the caller over here. So for version number 1, the caller over here is going to handle the error, and we are done. Version number 1. Version number 2, an error occur over here. The exception got propagated to the caller, but the caller only specifies the exception. It does not try to handle that, which means the same exception will be propagated further to its caller. In which case, let's say it will handle that somewhere. That'll be version number 2. And I'm pretty sure you can now imagine what version number 3 is, right? Error occur over here, gets propagated to the caller, who doesn't want to handle that, get propagated to its caller, who doesn't want to handle that. It will be propagated to the next level, which will be the console. So these are the 3 versions we want to see. I will try to show you both on the paper and also how you can visualize it in Eclipse. I think both are important. We should really finish that at least for today. And then the rest will just be straightforward, I think. All right, let's try. All right, it's really important for you to kind of understand the big picture. Some details which you cannot really follow, you can definitely refer to the recording. Okay, let me just make sure. Okay, I think we're doing okay with the time. All right, so I'll go back to Eclipse over here, and then let's try. The version 0, I'm going to keep it very clean, just a placeholder version. So what I will do, I believe I can just copy and paste, and I will call that version number 1. Okay, that's good. So version number 1. Still, we got A, B, and tester. Let me close everything from version 0. Okay, so this is something you should know. Number 1, if some error occur in your method, how do you throw an exception? In order to do that, you need a new keyword. Okay? And for the error over here, let's see. What you should do is, let me just refer to my notes. Okay, that's something you would say. Let me tell you the simplest syntax, and then we can understand what it really is. Remember we reviewed the anonymous objects from before, which is some objects without a name. All right? The new keyword you want to learn is called throw. By the way, throw and throws, they are both keywords in Java, but they are used in different contexts. In this case, where you want to throw the error out to your caller, it's called throw. When you specify to say, I might have that exception somewhere in my lines of code, that will be throws, different. Okay, just remember that. Throw, and then we want to throw a new exception. new. And in this case, usually for your lab 2 specifically, you can create your own exception. Of course, the JUnit test will suggest what the name should be for the exception class. Okay, for now, I'm going to follow my notes. It's going to be negative value exception. Just put that over here. Let me just make sure I did it correctly. Okay, and you can actually put some additional comments over here. Negative value. That will be the syntax. Don't worry about the red underline just yet. I'm going to talk about how to handle that. Okay. For now, let's review the syntax. Throw is a keyword you want to learn. This part over here is the anonymous objects that we reviewed before. And maybe after we have created a negative value exception class, I can show to you how you can rewrite this line in a way that might make more sense to you. Okay? Now, how do we create this exception class? You can make use of the auto generation feature in Eclipse. You can move your mouse over, and then it will show to you. I'll read it to you. It's a bit small. The negative value exception cannot be resolved to be a type, meaning that it doesn't exist in your project. Right? So you can see under the different fixes, the first one, create a class called negative value exception. That'll be the first choice. You can feel free to use this feature to generate. Okay? The definition for every exception class is very standard. So later in the programming test, you don't really have to memorize anything. You can just use the auto-gen feature. Okay? Click on that, and then just make sure it's stored in the same package, in this case, version 1. And then we're going to say finish. All right? All right, 1 here. Done. Except that there will be some standard, just one standard constructor that we can add, just to make the constructor more useful. I'll put it here. That's something simply, we have a constructor over here, which has the same name as the exception. And then you'll remember how we use it. This is the exception constructor, right? We actually expect to have some string value over here. All right? And over here, I can say string as some message. And then I'm going to use a keyword which will only be introduced when we talk about inheritance. But for now, you can just take it for granted. Okay? Super keyword. The definition for every exception class you might have to create for this course will look like just this, except that you want to change the name of the class and the constructor. Everything else will just be the same. All right. Let's go back to A here. You want to make sure you save the file. Okay. And then, let's see. Negative value exception. Okay. Are we okay so far? Okay. But we still have some error. But notice that the error we have now is a little bit different. We used to get underlined just this name, but we just created that class. But now we got red underline the whole line, which is different, right? Let's read it together. This one is saying this. You're throwing this exception here, but the unhandled exception type, negative value exception, this is saying you're throwing this exception here, but it's never handled in the caller Callee call chain. That's the problem, which we're going to solve. And to solve this, we got 3 different versions to solve it. Okay, let's see version 1. To really see all the possible solutions, you got to follow the catch with specified requirements, right? I will remind you always. Okay, let me just mention one more thing here. To handle the exception. Typically, you wouldn't handle it right in the method that throws the exception. Which means you can try later beyond the class, which I'm not gonna try this version because it's not really appropriate. You can simply wrap this particular exception in a try and catch block. It will handle that. But it's not the right place to handle it. Okay, just remember. Okay, let's see how we can handle that. If you just go back here, and then I'm gonna show to you We throw an exception here. We have created an exception clause. We have done the syntax correctly, but now it's complaining it's not being handled. Let's see where we can handle that. Option number 1. We can handle that right in its caller. That'll be version 1. How do we do that? Let's try. Okay. Let's now go to, Let's now go to, one more thing before I go to that class. If you remember the catch-word specify requirements, right? Even if you don't think you want to handle that particular exception, if you don't want to do the try and catch block right away, you have to make sure you specify that particular exception, which we forgot to do. Okay, let me do that. Let's go to Eclipse here, and then you can see in between the end of the parameter list and also the start of the method implementation. Now we're going to say throws that particular exception. Okay, you can see now as far as class A is concerned, no compilation error. The compilation error gets shifted to class B, who is the caller of this method. But let's look at class A very quickly. Okay? If you look at version 1, okay, that's version 1. Over here, we basically said 2 things. When the error occurs, if I is less than 0, we throw new exception, right? And of course, you got to create this exception class. In addition to it, we have to satisfy the catch or specify or catch requirements, which we did. It's part of the header, right? 2 things. The pink one over here is to satisfy the catch or specify requirements, right? In this case, it would be the specify option. And the orange part over here is to signal this is where the error occurs. All right, 2 things. And again, notice the keywords that's being used. One would be throw. The other one, throws. Don't confuse them. If you use the wrong keyword, you're going to get compilation error. And I can tell you that if you're still new to exception, it's kind of easy to forget. But just that means you got to remember. Are we okay with class A so far? Any confusion, just say it. Or you're okay. Okay? Yes. Yes, so here you can see that, yes, of course. So this is how you throw in a new error, like a new exception, yes. You got to use a throw keyword. Yes. It's the same. It's the same. So whatever I'm presenting here and whatever I put on the Eclipse, they are the same. Right? I just want to show to you, right, on the paper and on Eclipse. Right? If you're finding yourself, getting about 30%, 50%, I would say that's pretty good. As I said, exceptions are confusing when you first see that. I'm trying to present it in a clear way as much as possible. You definitely will need some hours of study on this and come back to me. All right? Let's continue. All right, let's now talk about, so class A has no problem now, but its caller, class B, has an issue. Can anybody guess what the issue is? Given our discussion so far, if I go to class B, line number 6 got some error. Can anybody try to guess if I move my mouse over that red underline at line number 6, what is Eclipse going to tell you? Which we saw earlier in class A, before we did the fix. Marcus. Yeah, that's actually correct, but can you give a little bit more information why you would think it's not being handled?
Because technically it's still running A, right?
Mm-hmm.
It's still going to technically throw the exception before, it's still going to run that.
Uh-huh, right.
So it's
Yeah. It's definitely on the right track. Okay, first of all, Marcus said 100% right. The error is going to be this line is not being handled properly, for sure. Let's move the mouse over. It says that unhandled exception type, negative value exception, meaning that you're making the method call on MA. But MA itself, if you go back here to class A, throws negative value exception. You're not really handling it. How do we handle that? Either catch or specify, right? Remember catch specify requirements? Always, if you want to handle some unhandled exception, either you can catch or you can specify. Catch means try and catch block. Specify means I'm going to throw that to my caller, next level. All right? Let's see for version number 1. Okay, so let me go back to class B over here. Let's say in this version, we handle the exception right here. Okay? The way to do it, let's try. We're going to have some try and catch block. Try and also catch. Okay, we'll fill in the precise information just now. Try and catch block, that's a syntax you should really practice. The try block over here is going to have some lines of code that might go wrong. In this case, OA.MA might go wrong because it might throw the negative value exception. That's why we put it here, number 1. Number 2, the catch part over here is going to say what kind of error might actually occur in the block of code over here. In that case, it would be, if you go back here, go back to class A, it's the negative value exception. You can copy that name and go back to class B, paste that name. And the catch block, in some ways, is more like a method declaration, in a way. So that means when you say this exception here, you can also give it a name. So you can manipulate the name inside the catch block as if it was like a parameter. Okay? So you can say maybe negative value exception, right? And now you can handle that exception. In this case, we are simply just going to say, let me just check very carefully over here. I'm just going to say system, the outer print line. Okay? Negative value, let me say caught in B dot MB. All right? And once I have done this, you can see there's no more error. A was fine, and it is still fine. B is fine, and we don't need to worry about tester. It's not really affected. All right? Any questions so far before I try to trace the code together with you? Everybody okay? All right. Let's now try to trace the code a little bit. Yeah, just don't forget, we actually got the try and catch block over here. Try and catch block, right? Okay, so now let's try to trace the code over here and see what's going to happen. I'll show you that on Eclipse as well. We now needed 2 notions of path for execution, normal versus abnormal. Let's do both. Let's start with the normal one, just as a warm-up. So I'm going to say normal input. Let me say, well, anything that's positive. Let's say 20. And I'm also going to try abnormal, which will trigger the exception. Let's say minus 10. All right, we're going to try one by one. Let's try with the normal one. We start with the tester. And then the user input our next int. Let's say they give us 20. All right? And then we create this object here, and then we try to call MB. And we're going to pass 20. Right? We go to MB over here, and we create OA, and we go to the try and catch block. And we go to OA.MA, we still pass the 20. And that means we're going to go to MA, and then we're going to check this if condition. So 20 less than 0 is false. So we don't go there. Don't throw the exception. So that means we're going to go to the else part and then do something. Okay? No exception. That's the normal case. Are you guys okay with this execution path? That's the normal one. Let's take a look at the abnormal one, which will not be too surprising, but we'll see. Also, I'm going to show to you on Eclipse. Abnormal, let's say minus 10. Okay? So we are reading just another input from user, so now it will be minus 10. We still create B, OB, and also call OB on minus 10. Okay, just another input, minus 10. That means we should go to MB, and then we still create the A objects and try. This time, when we call OA.MA, we're going to pass an illegal input, minus 10. All right? Minus 10, we're going to go to MA and see what happened. In this case, minus 10 less than 0. True. And we're going to execute this block of code. Okay? What's going to happen now? Because now we're going to throw the exception. When we say throw the exception, you can think about once this is done, once this is thrown, we're going to ignore the rest of the code in the MA. Well, there's no code anyway, but just kind of imagine if there are more lines of code in MA, we're just going to bypass them. We're going to skip. Okay? What this is going to happen is this MA over here is going to throw that negative value exception as soon as it is thrown. What's going to happen is it's actually going to go right away to the catch block. In this case, just only one catch block. And that catch block is actually going to catch it. And once it is caught, it's going to do something over here. All right? This is a very simple example here, but we'll see more later. So you can see more clearly like how lines of code might be interrupted. But for now, I think it's good to know the simple case. Are we okay so far? Just about how things should work? Normal versus abnormal. And I want to show to you very quickly, okay, on the Eclipse. And then we're done with version 1. And we're going to move on to version 2 and version 3. Let's go back to Eclipse over here. And then let me click on the tester over here. All right? The tester. So what I will do is I'm going to put a breakpoint right before the method call over here. Right? I'm not in the tester. I'm calling ob.mb. Okay? Let's try. Normal case. I'm going to launch. I can right-click on the tester and say debug as Java application. Okay? And then, why don't we try, let's say, 20. And let me switch to debug perspective. Okay, we're here, right? Now, rather than stepping over, we're going to step into the method call, right? Let's say we want to step into. So now we are in MB. And we're going to step over. And we're now executing OA.MA. Let's step into again. All right? And if we step into, we're now in MA. And I value is actually 20 over here. 20 less than 0 is false. So we're going to skip the throw new exception. So if you say step over again, well, actually the else part doesn't have any line of code, but at least you wouldn't go to the if statement, right? The if branch. That's the normal flow, all right? The reason I'm showing this to you is you might be asked, maybe in the lab, or at least in the written test, to show the different execution path. So just pay attention, all right? That's one, case number 1. Let's see case number 2. Let me stop it. Let me go back to the tester. Let's try some abnormal input. If I launch the debugger again, if I enter, let's say, minus 10, as we illustrated before, I'm here, all right? I'm going to say step into. I'm now in MB, right? I'm going to say step over. I'm now in this try block. And I'm going to step into once more. If I do that over here, now I know that I value is now minus 10. Minus 10 less than 0 is true. So if I step over again, I'm right before throwing that exception. What's going to happen? Let's remind ourselves very quickly. When we talk about it in the paper, we said before, if the exception was actually thrown from here, or thinking this way, we're now making this method call, and that method call is throwing this exception. If the exception is thrown from here, it's actually going to go directly to the catch block. That's what we will see. All right, just remember that. And let's go back to Eclipse, just confirm. All right, so now if I say step over, you can see we go to the catch block over here in the caller. This is where that exception got handled. And of course, if you say step over, it's going to print out the negative value caught, b.md. All right? Try to reproduce what I'm doing here in the Eclipse. It's really important for your understanding. The most confusing part about understanding exception is about understanding a call stack. That's the most confusing part. You need to practice. All right? Now, that's about version number 1. Do we have any question before we move on to version 2 and 3, which can be done a little bit quicker? Okay? Guys, any question, please? Hopefully it's not too bad, right? Yeah. Yes, please.
So, then the next version, so you know how we do the try and catch
Yeah.
last page. So if we were to do it in tester,
Yeah.
would we be able to get them to re-enter a number?
Yes, indeed. So, Marcus, if I understood your question correctly, are you saying, can we try, rather than handling the exception in B, we want to handle the exception in tester? In which case, can we still read the input from the user?
Yeah, so they re-input.
Yes, re-input. That's something we'll talk about maybe on Monday. I do have some example code to show to you. Yes, that's possible. Yes. Yes?
Before the exception, if you have a parameter or a string,
Yes.
is it like a constructor? Is it like that, like how it knows where to catch it?
Good question. No, the answer is no. The question was, is the purpose of this string message over here for us to identify this exception over here? No, because typically the error message put here is only for human to read. So later on, if anybody would like to inspect this exception object, they can look at what's really going on over there. But for Java runtime to see where this exception comes from, they don't need that. They have some sophisticated mechanism to recognize it. Yeah, you will find the right one, yes. So I think that's something we'll see a little bit more later. So in a more general scenario, after this line over here, imagine after this line, there might be more lines of code in this particular if branch. And also, there might be multiple catch blocks, in which case, you will have to trace more carefully, which I'll do on Monday. For now, I think this is simple enough, just good enough. All right, good. All right, any more questions about version 1? And why don't we take a short break by taking attendance? All right, why don't we do that? Okay. And then we'll move on to version 2 and 3. All right. Let me start a class over here. And then I'm going to present a normal, very dumb question on the iPad. Give me a moment. Okay. Yeah, please do it now. If you cannot really check in or answer the poll, please raise your hand right away. Yes, I'm not going to deal with any issues after I end the poll. Everybody's okay? All right. I can wait for maybe 10 more seconds. Everybody was ready, which is good. Okay. 5, 4, 3, 2, 1. No issue, right? I can close it? Awesome. Thank you so much. All right. Done. Okay. Let me end it. Oh, did I just... Okay, we'll take another 10-second break because I accidentally quit my iPad, which is not very pleasant. Give me a moment. You'll be quick to bring it back. All right, I will go to my iPad again. There we go. All right. Sorry for the interruption. And we should now talk about version number 2 and version number 3, right? That's what we should do. Just give me a moment. But I think it might be nice since we took some break. So why don't we do a very quick recap about version 1? And we definitely should finish version 2 and version 3 today. All right, let me just move that to over here. All right, good. Okay, version 1. We created this, oh, sorry, not here. Beg your pardon, over here. For version number 1, right, we created an exception class called this, negative value exception. You can use Eclipse to do it. And the keyword to use when you want to throw an exception is to use throw. From then on, for every involved caller, you can choose to either use the you can choose to use either the catch or specify option, okay? Usually, in the same method that has the exception thrown, you wouldn't choose the catch option to handle that. So normally, we just say specify. So for version number 1, the exception will be propagated to its caller, in which case we choose to specify it. Sorry, in which case we choose to catch it. That's why you see the try and catch block. All right, that's version number 1. And we're going to see for version number 2 and 3, different flavors, different possibilities. Let's talk about version number 2. Let's do it. Okay, let me now stop the debugger. I believe it's stopped. And let's go here. All right. And why don't I just make a copy of version 1, okay? And then I'm going to call that version 2. Then let's see what we should change. And so you can see exactly what the difference is between version 1 and version 2. Okay, for version number 2, class A, we don't need to make any changes, the same. Again, in the same class or in the same method where the exception is thrown, normally you will only just specify it. You don't really handle that right away. Okay, that's a principle. Let's go to class B. You know what? Let me close every class. Otherwise, I might just get myself confused. Let's try. Okay, for class B in version 2, what should we do? We used to handle that right here, the catch option. Let's try the specify option, meaning that we don't want to handle it. Let me get rid of the try block. So let me just put the comments here. We just specify the exception without handling it. How do we do that? Okay, first of all, I'm going to get rid of the try and catch block. That's all I will do. All right, so here you can see if I only have the method call over here. Okay, let me also get rid of this. Clear. If I only have this line, it's going to be an error because the exception has not been handled. We should do either catch or specify. We try the catch in version 1. Let's try specify. If we do the specify option, it's going to be put in between, right? Throws negative value exception. So now, as far as class B is concerned, it has no error because we definitely satisfy the catch or specify requirements. We are not specifying it, right? That's how we specify it. So now when you compare version 1 and version 2, notice the difference on class B. In version 1, we try to catch it. In version 2, we try to specify it. And we're not done because in the tester over here, we got an error. All right? Exactly in line number 13. Okay, anybody try to explain? What kind of error is that in line number 13? Before I point to Marcus, which I'm pretty sure he knows the answer. Okay, anybody, don't be shy, try to answer. Why is there an error in line number 13? Yes, please. It's not handled, okay? To be more precise, I will help you a little bit to elaborate. It's not handled because in this tester, to be more precise, it's not handled. Number 1, it's not being specified. In this main method here, you can see in between these two symbols, there's no throws, number 1. Number 2, around this method call here, there is no try and catch, so there's no catch. There's neither catch nor specify, so that's why it's not handled, okay? Are we good with this? Well, let's try. Well, let's try to handle that right here. In this version, we try to handle catch the exception here. All right? I'm going to say try here. Very similar code, right? I'm just going to put the line that might throw the exception in the try block. Apparently, the callee might throw the exception, because if you look at MB over here, it might throw the exception, right? I'm just reminding you how you can see the information. Go back to tester, and we're going to do catch. And in this case, just make it simple. We just specify just one kind of exception. Negative value exception, negative value exception. By the way, the name here is just like a normal parameter name. It can be any name you like, all right? Okay, and here we can say it's just in the outer print line. Over here, oh, can be error, but let's just put out. Error caught. In this case, we are now in the tester method. All right. And after this, no error. Quick recap. Version number 2, for class B, we changed from specify, sorry, let me say it again. For version number 2, in class B, we changed from catch to specify. And then in the tester class, we do the catch. Okay? And let's now try to trace the code quickly. And then we're going to move on to version number 3. All right? We still have some time. Version number 2. All right? You can see class A doesn't change. All right? You still throw that exception out and specify it. Let me remind you, this guy over here is the specify option. And for class B, this is where the change is. We also try to specify it. And in the tester class, this is where we try to catch it or handle that. This is so-called exception handler, right? The exception handler, in theory, can happen in anywhere in the call stack, all right? Exception handler. All right? Do you have any questions so far about the code before I maybe trace something together with you? All right, we should trace. Of course, there's another possibility, which would be version number 3. What if the tester doesn't want to catch that? Meaning that you also specify it. What's going to happen? We're going to see. All right, let's now try to trace some input. And let's now be more focused this time. Let's say we try some abnormal input. Let's say the user enters maybe -10, like before. Okay, let's give it a try. The user is going to give you back -10. And then, when you do the try, you're going to say ob.mb. And the I here will be -10. And we're going to step into the execution of MB over here. And the I here is going to be -10. And create A, and we try to make this method call over here. And the value will be -10. No exception thrown just yet. And we're going to execute MA over here. And -10, of course, it's -10 we are passing. -10 less than 0, true. That means we are actually going to execute this line to create and throw that exception objects. As soon as the exception is thrown, the flow will be disrupted, meaning that here, this line here, right, you can see this MA, also MA over here. This line here will throw. It's the negative value exception. As soon as it is thrown, it's going to be look for if there's anything that's being handled that can handle the exception over here. The answer is no, because in here, we only specify it. That means it's going to be propagated. is going to be propagated to over here. Here, do we have an exception handler? We do. Because you can see this method call over here does have the try and catch block wrap around. So this is where it got handled. Okay, let me just try to explain one more time. After this is thrown, meaning that this method call throws that exception. Java runtime will try to see if this line got the exception, do you have any catch was specified? Indeed, you have to specify, meaning that we are going to propagate this exception to the caller in call stack. And then in this class over here, same question. Because this method call is actually from here, right? And do we have any handler to handle this? Either catch or specify. Yes, because that's within a try and catch block. So this is where things got handled, and we're done. No more propagation. Okay? Okay, so this one here, this is where the exception gets handled. Right? If you look at the diagram very quickly, so you also see the diagram in your slides. This is a call chain from the main to b.mb and then to a.ma. That's a call chain. When error occurs over here, the exception got propagated to the caller, which only specified the exception. And then it gets propagated further, and in this case, it gets handled by the try and catch, and we're done. That's version number 2. All right? Any question? I will just like to finish version number 3 for today. I think that'll be enough. Yes, question? Sure, good question. You're saying that neither specifies nor catches, right? Is that what you meant?
Well, like, what if it's the tester still catches, but for class B, it just specifies?
Okay, good question. Let's try right away. The question was, at this point, we know that try and catch over here, and then we are trying to say, what if there's no specify here? What's going to happen? Okay. Before I show to you on Eclipse, just remember every level of the call stack must satisfy the catch with specify requirements. If you got rid of this, is this class trying to somehow satisfy the requirements? Not really, because you kind of missed the specify. Let's try right away. Okay. Let's go to Eclipse over here and do what you kind of suggested. Let's go to class B. And then get rid of it. Error. And what you will see is a very good question. Now, if you move your mouse over, unhandle exception. So guys, what I just did, which is also very important, was like this. If you have the following scenario, this level here, throw the exception, right? Let's say. This one here, immediate caller, doesn't do anything. But you try to catch the exception over here. That's the scenario I just showed to you. This one here, but in this middle level here, nothing has happened. It will still give you an error because every level in the call stack must do something until the exception is handled. Answer your question, I hope? Very good. Very good question. There is another scenario, which I think I'll mention maybe a little bit later. Okay. All right, and let me just change it back, and then let's do version number 3 very quickly. So important. Okay, we got about 3 minutes. We'll see how much we can do. All right. All right, for version number 3. Let's now try to copy version number 2, and I'll name it version number 3. All right. For version number 3, let me just close everything first, just to avoid confusion. Class A wouldn't change. It is the source of the exception. For class B, wouldn't change because we don't want to handle that, so that's why we specify. For the tester over here, now the change would be we don't want to handle that using the try and catch block. Let's try that. Okay? So in this version, we do not want to. handle the exception here. Meaning that we're going to do something like that. And of course, at this point, similar question as before. Why do we have an error in line number 15? Because neither catch nor specify is done here. So since we don't want to do catch, why don't we do specify? And I can tell you that this is theoretically possible, syntactically it's allowed, but you wouldn't do that normally. But I'll just show to you. Throws negative value exception, right? You can see I'm really trying to enumerate all the possibilities over here. Everything is logical, right? Now, no error. Let me execute the code right away, and then we'll trace the code, and then we're done. Tester over here, and if I try to execute it, right? If I say -20, what's going to happen? Exception will be somehow being propagated to the tester, but the tester itself does not want to handle that. That's why in the main method header, you say throws that exception. So the exception will be thrown back to the terminal, which you might see sometimes, actually. Let's say -20, and that's exactly what you will see. That's the exception, negative value exception, which was never handled properly, which was never caught. So that's why it's thrown back to the terminal. That's a final level. All right? Just 1 or 2 minutes. Let me trace the abnormal input, and then we'll continue next time. Okay? Let me do that quickly. 1 or 2 minutes. Okay. Let's say we are now doing abnormal input. Let's say -20. All right? So we start with the tester here, and then we got input I, -20. And we're making the method call ob.mb, -20. So now we're executing mb, -20, which will in turn call oa.ma, in which case we also passed -20. And then when we call this with -20, now you can see -20 less than 0 is true. We are indeed going to throw this exception. So far, we have been showing how the call stack has been built, the purple one. As soon as the exception has occurred, let me use a different color. So this one here is going to be thrown to this line here. This is where the method call was made. And at this point, we only specify, meaning that we're going to propagate this exception further to the caller. Right? This is where the method call was made. And then this one here also try to specify. So after that, it's just going to be propagated to the terminal. Propagated to terminal. Quick summary. This is where the error occurs. Go to its caller, which specify it. Go to its caller, which specify it. In which case, we're going to throw to the ultimate level, which will be the console. What should you do before Monday? Of course, you're going to study hard on your programming test, but meanwhile, exception is so important, right? The best way you can get prepared for Monday's lecture, for Monday we're going to do more example, maybe more complicated. To get prepared for that, study the to handle or not to handle example very carefully. Use Debugger, trace the code by yourself, and also read the slides, all right? Guys, any last minute question for me before I let you go? Thank you so much, and then have a good weekend. I'll see you next Monday.